Well, welcome to this AQA FP2 session. In this session we will be covering the January 2011 question 1 exam question, which was on the topic of complex numbers. See, this question has two parts. In the first part you are asked to sketch on an Argand diagram the points which satisfy the modulus of z minus 4 plus 3i equals 5. And that is in the standard form of the equation of a circle, or the form z minus a, then take its modulus and it's equal to r, where r is the radius and a is the centre of the circle. And in part B you can see we're then asked to indicate on a diagram where z1 is, where the argument of z1 is equal to 0, and then also to find the modulus of that particular number. Well, before you start to sketch the Argand diagram in part A, key thing would be to get that into the correct form that you require. So this would be the same as the modulus of z minus, and so this becomes 4 minus 3i. By writing it in this form, you ensure that you get the centre of the circle in the correct place, because you now know the centre of the circle is at 4 minus 3i, and the radius of the circle is 5. And those two things are key if you're going to draw or sketch the correct diagram for this particular locus. And so you can see, here's one I did earlier, and so the radius of this circle is 5, and the key thing is that the centre of this circle is going to be at the point 4 minus 3i, and we said the radius is 5, and so it is key that you get the circle in the correct position relative to the axes and also relative to the origin, because the point 4 minus 3i has a modulus which is going to be the square root of 4 squared plus negative 3 squared, which of course you should know is a 4-3-5 triangle. So its distance from the origin is 5, so the origin must lie on the edge of the circle. So that is key that it goes through this point. Okay, so having done that, then in part B it then asks you to mark the point z1 where the argument of z1 is equal to 0. Now you should know that this line going in this direction has an argument of 0, and so the key point that you want is going to be here at this point. So this is going to be the point z1. Now notice there is only one point for z1. Though the origin lies on that line, remember the origin will not have an argument because it is not defined at that point. Right, because remember the argument is tan to the minus 1 of the imaginary over the real, and if the real value is 0 you're dividing by 0, therefore it's not defined at that particular point. So z1 is the only point we've got. Now in the second part of part B it asks you to find the value of that modulus of z1. And the easiest way to do that is to just use the symmetry of the diagram, because we know that the centre of the circle was at 4 minus 3, so from the origin to halfway along this line is 4, and so z1 must be at 8, so the modulus of z1 must be equal to 8. It's just its distance from the origin. So where did you get your 5 marks? Well, for drawing a circle, that is obviously going to give you 1 mark. For then having the correct position for the centre of the circle, that is going to give you 1 mark. And then for having the circle passing through the origin, that will give you the 3rd mark. Then in part B, you get 1 mark for marking Z1 in the correct place. Obviously, if you haven't had the correct diagram, they'll still be generous and give you a mark if you've marked a point on the real axis. And then finally, for getting Z, the modulus of Z1 equal to 8, you will get the final mark to give you the 5 marks altogether. Well, if you have enjoyed that particular question and you wish to find more questions and support for your work, please go to the Further Maths website.